This is a video for AQA Mechanics, Work, Energy and Power, section 1.4, where we're looking at potential energy. Well, potential energy is a type of mechanical energy which is due to position. And we can think of potential energy as being a store in an object which gives its potential to move when released. There are two main types, gravitational potential energy and elastic potential energy. In this video we'll be considering the gravitational potential energy. Elastic potential energy we'll deal with in later videos. Well, we know that all bodies with mass have a force acting on them, which is the gravitational pull towards the Earth. So the force is proportional to the mass and is equal to the mass multiplied by the acceleration due to gravity. So we have that W, the weight, is equal to mg. M is the mass in kilograms, G is acceleration due to gravity, which we normally take to be 9.8 meters per second squared. Well, it does vary from place to place, so this is an average, and sometimes it can be approximated to 10 meters per second squared. If an object moves vertically, then it's moving either because of its weight or against its own weight. Hence we've got, by the work energy principle, that the work done gives us a gain in the energy. We know that the work done is the force, W, multiplied by the height. And we know that that W we've just discussed is equal to mg. So we have therefore the potential energy is mgh, where h is the change in the height. So if we move something through a height h, then the gravitational potential energy gain is mgh. And this is then stored, and if we release the object, that energy can then become kinetic energy as the object falls to the ground. Well, an example of where this might be useful is in a hydroelectric scheme where the water which is held behind the dam has got a store of potential energy, and if we then open the sluice gates at the bottom, that turns into kinetic energy of the water, which in turn can drive the turbines and produce electric energy. Right, now I want to look at a couple of examples where we're using this idea that the gravitational potential energy is equal to mgh. So here we have a 30-gram mass which is pushed up a 2-meter slope which is inclined at 60 degrees as in the diagram, and we want to find the gain in the potential energy. Well, the first thing of course to work out is the actual gain in height, h, and we can see from the diagram that h will be equal to 2 sine 60. Sine 60 is root 3 over 2, so 2 sine 60 is root 3. So the gain in height is root 3 meters, and therefore the gain in gravitational potential energy, mgh, is equal to the mass 30 grams. 30 grams is 0.03 kilograms, G 9.8, and H root 3. And that to three significant figures is 0.509 energy, so units joules. In the second example, we're asked to consider a 5 kilogram mass which is held 10 meters above the ground and then released. So we want to find the change in the gravitational potential energy and the kinetic energy just as it hits the ground. First of all, the change in the gravitational potential energy is mgh, so that's equal to 5 multiplied by 9.8 multiplied by 10, which is 490 joules. Now the kinetic energy, to get the kinetic energy we need a half mv squared, and therefore we need first of all to calculate v squared. We can use equations of motion, so v squared is equal to u squared plus 2as, but we know that u is 0, therefore we've got 2 multiplied by 9.8 multiplied by 10, which is 196. So v squared is 196, so when it reaches the bottom, the kinetic energy is 1/2 multiplied by the mass 5 multiplied by 196, and that turns out to be 490 joules. So you can see that then in falling, the gravitational potential energy that has been lost has been turned into kinetic energy. So this is equal to then the work done by gravity. So it's both the gain in the kinetic energy and the loss in the gravitational potential energy equal to 490 joules. So we can see with that then that we've actually got a conservation of energy there from the gravitational potential energy turning into kinetic energy, and indeed it is that we'll be considering in the next video.